All right, fam, moving right along. Here's problem number 3, graphing horizontal and vertical lines. Now, technically, when you plug in zeros, you don't need to solve, but what it does is it graphs a dot, okay? So when you plug in a 0 and you make one of the x and the y values go away, then either you're gonna end up with a vertical line or horizontal line. So they write it out all crazy like this, like, oh, 1x plus 0y equals 3 in standard form. 0, okay, but here's the thing. If you see a lone x all by itself and it equals a number, that number is going to tell you exactly where to graph a vertical line, okay? Why? Well, if you find out where x equals 3, 1, 2, 3, oh, that's where x equals 3. Now, where does every single x value equal 3? Here, 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 everywhere down that red line. Every single x coordinate in that line is 3, okay? Over here, y equals 3. Where does y equal 3? Right there. And then you make a horizontal line. Technically, this isn't slope-intercept form. It just doesn't have slope. It has a 0 slope. Remember 0 slope? Okay. This one can never be written in slope-intercept form because, remember, vertical lines have an undefined slope. But they do have their own equation. X equals a number, always going to be a vertical line through that number. Y equals a number, always going to be a horizontal line through that number. Okay. So I'm going to graph all 4 of these on one graph. I believe on your notes, they each have their own graph, but just for saving space, I'm going to graph all of these on one graph here. Here we go. So x equals 4. First of all, where does x equal 4? Here's x, here's y. X equals 4. 1, 2, 3, 4. There we go. Now I'm going to make a vertical line. Okay. Every single coordinate point on that line is going to have a coordinate point of 4. Every single x coordinate. There's 4 and 0, 4 and 1, 4 and 2, 4 and 3, 4 and 4. So instead of just finding the coordinate point 4, it's kind of like saying everything on this line has to equal 4 for x. So it's like taking this line and you just shove it over 4 units. Okay, it's kind of weird, but that's where my mind goes. X equals a -1. Okay, x equals -1 right here. Okay, vertical line. So it's taking this whole line and moving everything over one to the left. Okay, it's like a super, not a super coordinate point, but it's like a super move. Okay. It's like an official statement. Hey, everything's 4 to the right. Hey, everything's 1 to the left. Then it comes to vertical lines. Now, horizontal lines. This is kind of a weird one. I'm going to skip this one. Here we go. Here's D. Y equals 1. Where does y equal 1? Right here. Oops, I didn't label this line. Sorry. There you go. Where does y equal 1? Right here. So then that's a horizontal line. As you can see, things get kind of crowded here really quick. All right. Now, why did I say the one for last? Y equals 0. It's kind of a tricky one. Where does y equal 0? Right here. Now, where does every single y value equal 0? I kind of already said this. On the x-axis, y always equals 0. So when it says y equals 0, technically what you do is you graph right over the x-axis. So it's kind of a weird one. Totally agree. Okay, there you go. So that's y equals 1. This is y equals 0. You get the idea? All right, there you go. So that's y equals -1. There you go. You knew that, but I was going to make sure you did. Okay, all right, that's it. That's vertical lines and horizontal lines. Every single equation where it says x equals number is a vertical line. Every single y equals a number is a horizontal. End of story. Okay. That's example 3. All right, bye.